Okay, so today we're going to work through the Unit 4 review. Just like with the other videos, this video is to help you with the review. This is, I don't want y'all just watching, copying it down, yada, yada, yada. This is me explaining how to do the problems. That way, when you see them on the test, you'll know how to do them, in case you forgot how. So with that being said, let's look at number 1. For number 1, they give us the classification of the triangles. Or sorry, they give us the angles of the triangles and we have to classify them. Said that totally wrong. But anyways, they give us the angles and then we have to classify them based on those angles. So if we look at A, let's see, I see 18 degrees, 40 degrees, 122 degrees. That angle is an obtuse angle, which makes this triangle an obtuse triangle. Remember, obtuse triangles have one obtuse angle. If we look at the next one, we've got 35, 90, 55. This 90 right here tells us what kind we have. The 90 is a right angle, and that makes this a right triangle. Okay, so for number 2, we have to classify each triangle by its angle measures and its side lengths. So you'll notice that A has 4 blanks. Let's first do angle measures. So a triangle that has 3 angles that are 60 degrees each is called an equiangular triangle. Excuse me. But since they're all acute angles, 60 degrees is an acute angle, and we've got 3 of them, this is also an acute triangle. Now let's go by side lengths. All 3 sides are the same, so this is called an equilateral triangle. But also, an equilateral is an isosceles triangle. Remember, isosceles has to have at least 2 sides the same. We have 3, which last time I checked is at least 2. So it qualifies as an isosceles triangle as well. Now let's look at B. For B, if we're doing it by angles first, we see an obtuse angle, which makes this an obtuse triangle. Then we need to look at our sides. I don't see any sides that are the same. That's what these marks are showing us. It's showing us all sides are different. If all sides are different, this is called a scaling triangle. And then for C, we have a right angle here, which as soon as you see that right angle, automatically makes this a right triangle. Now let's look at the sides. They tell us that 2 sides are the same. So this is an isosceles right triangle. So you need to be able to classify triangles. Number 3, they give us 2 angles of the triangle, and we have to find the 3rd angle. Remember, all triangles add to equal 180. So if you want to find that 3rd angle, you need to add the 2 you're given together and then subtract from 180. So we would want to do 23 plus 88 to get 111, and then subtract that from 180. And that gets us 69. So this third angle is going to be 69 degrees. Now for B we've got to add together 43 plus 47, which gets us 90. And then subtract that from 180, and again we end up with 90. So this third angle has to be 90 degrees. Number 4, can the pair of angles given be the acute angles of a right triangle? Yes or no? Well, so they're telling us this is a right triangle, which means each of these triangles will have a 90-degree angle. So what I can do is I can go and add up these angles. So 90 plus 21 plus 73. If I add all three of those up, then let's see, I get 184. Can a triangle have 184 degrees? No, that's greater than 180. So this would be a no. That's bad. 184, no. We can't have a triangle with 184. So that is no good. Now let's look at the next one. We got our 90-degree angle because it's a right triangle. But then we can add up the rest. Plus 34 plus 56. Give us 10, carry your 1, that's 10, 180. Is that good? Yes, that's good. This is a good thing. 180 is good because we have a triangle. So this one is yes. Okay, number 5. On 5, you're dealing with remote interior angles. So this angle that's outside is our exterior. That means these two are remote interior angles. And we've learned for remote interior angles, you can add them together and set them equal to that exterior angle. So I would have 37 plus 55 equals x. So you add them together and set it equal to the outside one. 37 plus 55 is 92. So x equals 92. X equals 92. That's our answer. Now on to the next one. So these are our remote interior angles. So we'll want to add them. And then we'll want to set them equal to this one, which is our exterior. So let's do that. This box right here means it's 90 degrees. That's a right angle. So I'll have 5x plus 90 equals 20x minus 15. I'm going to move the 5x over because I want to keep everything positive. It's going to be 90 equals 15x minus 15. Add 15 to both sides. We get 105 equals 15x. Divide by 15. And we'll end up with x equals 7. Now for number 6. So number 6 asks us to find the length of AB. Well, here's AB right there, but I've got a Z in there. What do I notice though about all my sides? These marks tell me that all sides are the same. So to get the Z, I can say 4Z minus 4 equals 3Z minus 1. Subtract the 3Z from both sides. I'll get Z minus 4 equals negative 1. Add 4. You get Z equals 3. Are we done though? No, we have to find AB. That's what they tell us up here. So that means we have to plug it in, plug it in. So AB equals 4 times 3 minus 4, which is 8. Therefore, AB equals 8. Okay, number 7. 7 asks us to find the value of x. Well, what do we notice? All the angles are the same. So that means, or all the sides are the same, which means all the angles have to be the same. So that means these all have to be 60 degrees. But wait a minute, if M is 60 and M is also 45 plus 3x, that means those are equal to each other. So to get x, we can say 45 plus 3x equals 60. Then subtract 45 from both sides. It's going to get you 3x equals 15. Divide by 3, and we get x equals 5. And that's what they ask us to find is x. So that's our final answer. X equals 5. Okay, number 8. 8, we have an isosceles triangle here. See these two lines? Means it's isosceles, which means our base angles would be the 3x and the 69. So those are equal to each other. So how can we get x? Well, we say 3x equals 69. Divide by 3. And we end up with x equals 23. And that's our answer, because that's all they ask us to find. Now, number 9, find the value of x. Well, what do all the angles in the triangle have to add to? 180. So let's say you didn't pick up on the shortcut here, but you knew they all had to add to 180. We could say x plus x equals 180, which means we have 3x equals 180. Divide by 3, and we get x equals 60. Now, you could have saved all this work and said, wait a minute, all the sides are the same. That means all the angles are the same, and they're all 60. Oh, that means x equals 60, and you wouldn't have to do any algebra. But if you didn't realize that, then that's where this algebra comes in. X plus x equals 180. Oh, okay, I can solve that now. So there's two ways you could have done this one. Easy way, and a short way, or a long way. Either way, you get the same answer. Okay, number 10. A triangular chime is a steel musical instrument sometimes used in an orchestra. The figure below gives the dimensions of one chime. How many chimes could be made from 163 inches of steel? Okay. So we've got 163 inches we can play with here. Or we're not playing, we're building. Well, how much can we make for one triangle? So one triangle. 6 plus 6 plus 6 gives us 18 inches. We've got 163 total though. So you can say 163 divided by 18. And that gets you about 9.056. Now, if you wanted this musical instrument, would you be willing to purchase 0.056 of a triangle? No. So really, he can only make 9 of the chimes. This 0.056 would be turned into scrap. He can only make 9 of them. Okay, number 11. So 11 asks us to find the length of BD. There's BD. Now they tell me that 5.5, so those are the same. If the diagonals from A to B and A to D are the same, that means AC is a perpendicular bisector. So BC has to also be 3.7. So to get the whole thing, you just have to do 3.7 plus 3.7. So let's see, that's going to be 14, carry your 1, 7.4. So what's the length of BD? BD is 7.4. That's all there is to it. Now they ask you to find JL. Again, we have a perpendicular bisector. The line LM is perpendicular to JK, and it's cutting JK in half. So that means JL and LK have to be the same. So JL 7.9. Well, I think we just answered our question. Found the length of JL. JL is 7.9. Number 13. Given that the measure of angle SRT is congruent to URT, so SRT is congruent to URT, find UT. Well, that means RT, since SRT is congruent to URT, RT is an angle bisector, which means ST and UT have to be both 36. They have to be congruent. So find UT. Well, UT equals 36. Okay, it says YV is a perpendicular bisector of XZ. What's the value of N? And YZ is the perpendicular bisector of XZ. That means YX and YZ have to be congruent. So to get N, we need to set them equal. 8n minus 9 equals 3n plus 5. Now let's move the 3n over. We're going to get 5n minus 9 equals 5. Add 9. We get 5n equals 14. Divide by 5. And you get, since this is a nice decimal, I'm going to write it, well, I guess I'll write it both ways. You can say 14 over 5, or you could say 2.8. Either way is acceptable. Yeah, for 15, they ask us which term accurately describes TY in each diagram. So perpendicular bisector, well, let's find that one. Which one of our diagrams is a perpendicular bisector? Remember, bisector means it cuts something in half. So I see the first one, second one, and the last one do it. But then perpendicular, that means it intersects at a 90-degree angle. Oh, only one of those do that. So our perpendicular bisector is this last one. And then it says we gotta find the angle bisector. Again, bisectors cut something in half. That's the first and last one now that we're left with. But here we want to cut an angle in half. So that's going to be this second one here. TY cuts that angle in half. So this is our angle bisector. The median. The median starts at a vertex and then goes down and cuts the opposite side in half. That's exactly what this first one does. Which means the last one is altitude. That's where we start at a vertex and then go straight down. So you drop it like it's hot. Okay, 16. 16 tells us that triangle PQR is congruent to triangle STU. They ask us to find a couple of things. First, we want to find M. There's our M. And we've got a side. PR is congruent to SU. So I can set 3M plus 2. 3M plus 2 equal to 14. Subtract my 2. I get 3M equals 12. Divide by 3. And I get M equals 4. Then they asked me to find Y. Oh, now I've got two angles that I know are congruent because they tell me the triangles are congruent. So P and S are congruent to each other. So to get Y, you can just simply say 2Y equals 46 and divide by 2. It's going to give us Y equals 23. And that's our answer. Y equals 23. Okie dokie. Number 17. Given that triangle JKL is congruent to triangle DEF, identify the corresponding parts. So first they ask us about KL. Well, what side on the other triangle goes with KL? That would be EF. So this would be segment EF. Then we have segment DF. That would have to go with JL. Remember, you gotta have them in the same spot. DF goes with JL. Then they have angle K. K is our second angle. So that goes with E. Angle E. And then last but not least, they ask us about angle F. F goes with L. So angle L. Okay, number 18. Given that R is congruent to M, S is congruent to N, T is congruent to O, all those segments are congruent, what's the congruent statement? Well, just like we saw in 17, the congruent statement has to list the corresponding parts in the same order. So R is congruent to M. So in both spots, R and M, I'm going to put first. S is congruent to N. And then T is congruent to O. My angles are all in the same order. Then I could just double check. RS, MN, that lines up. ST, NO, that lines up. RT and MO, those line up. So really, I just had to use my angles. RST, MNO. That's all there was to that one. And number 19. 19, we have to find something it looks like. So they say JKL is congruent to EFG. JK is 6, KL is 10, JL is 5. What is FG? Well, let's see here. FG. So FG is right here. Which one's congruent to FG? KL. So FG is equal to KL. Well, what's KL equal to? KL equals 10. So that means that FG equals 10. Okay, number 20. State whether the triangles are congruent by side, 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 angle, angle, AAS, HL, are not congruent. Okay. So, like I've said in class, I recommend marking the parts they give you. That's a great start. Mark what they give you. For A, they say side. They give you a side, and a side. Huh. I bet this one is SSS. And it is. This one's congruent by SSS. Now for B, A. Do we have an AAA? No, there is no AAA. So since I don't have one that says AAA, I have to say not congruent. Like I said in class, I ain't AAA, I ain't gonna pick you up. Okay, now let's look at C. First thing I noticed, they cross right here. This is vertical angles. So that means these are congruent. So let's label what I know. I know an angle, and a side. So it's either going to be ASA or AAS, but which one? Well, that depends on where the side is. Is our side sandwiched in between the angles? So is it right there? No. If it's not sandwiched in between the angles, then we can't write it in between the angles. So we have to say congruent by AAS. Okay, then we have the next one. So the first thing I notice is it's a right angle. Aha! We may have something for that. We've got a special case that deals with right angles. Let's see if we meet the requirements for it. So we've got our right angle. So we've got our right angle. Is the hypotenuse congruent? That's the long side. Yes, right there. So hypotenuse is good. Do we have a leg that's congruent? Yeah, a leg is just another side. So yes, we have a leg congruent. Well, what's this one congruent by then? This is congruent by hypotenuse leg. Okay, let's look at E. First thing I notice on E, I've got some vertical angles. So I'm going to mark them. And then I'm going to go through, I'll see 3 pieces, so let's label my 3. Side, angle, side. So I've got 2 sides with the angle in between. 2 sides are making my angle. That's the definition of side, angle, side. So this is congruent by side, angle, side. Okay, next one. Let's see, I see a right angle. Ooh, I may have another HL. Let's check. I've got my right angle here. So here's my right angle. But my hypotenuse, I don't know anything about that. So I can't use HL. Darn the luck, but it ain't happening. No HL here. But what do I see? I also see some vertical angles. So let's label what we're given. I have an angle, a side, and an angle. Okay, so again, 2 angles and a side. Is my side sandwiched in between my 2 angles? Yes. I have 2 angles that sandwich that side in there. So that means this one is congruent by angle, side, angle. Okay, 21. What additional information do you need in order to prove the 2 triangles congruent by ASA? let's see. I want to use ASA. So I know I have two angles here. Where does my side have to be if it's ASA? Angle, side, angle. It has to be the one that's sandwiched in between. That's got to be my S. So what I really need to know for sure is that FD is congruent to AC. I think I said that backwards. Yep, I did. FD is congruent to CA. I have to know that to use angle, side, angle. So let me kind of reconstruct this angle. So that's what needs to happen. I need to know that FD is congruent to CA. Oh, let me change my text color right quick. Okay, now on 22, they're talking about similarity postulates. We didn't cover this year. So you actually do not have to worry about number 22. We didn't cover it. I'm not going to hold you responsible for it. So I'm going to write all caps right here. Did not cover. Not responsible for it, for this. Okay, let's look at 23. Okay, now for 23, what's the length of FH? We can do this. This is dealing with ratios and similar triangles. So yeah, we can do this one. We want to find the length of FH. Well, what side does FH go with? Well, G and C are congruent. I know that because it's marked. So that means FH has to go with BD. Those two go together. Let's just call this X. So I can set up some ratios here. I can say that X over 30 equals 14.5 over 58. And then this becomes just the cross product or the butterfly method. So 58 times X equals 14.5 times 30. Well, let's see, what is 14.5 times 30? It's going to be 435. So 58x equals 435. Divide by 58. And we get x equals 7.5. Well, our x represents FH. So that means that FH is 7.5. Okay, 24. Again, we're using the fact that these are similar to each other. These triangles are similar to each other. That's the fact that we're using. So 12 and 8, if I add them together, I can get my whole big triangle. My whole big triangle here, 12 plus 8 is 20 on that side. Now they ask me for the length of CE. So they want to know, okay, what's this? Well, let's see. Let's just call it X. Let's call it X. That means this whole side then is 15 plus X. So I can set up a ratio, big triangle to little triangle. Or sorry, maybe we want to do, yeah, let's do big over little. Big over little. So 15 plus X over 15, big over little, equals big, which is 20, over 12. So let's cross multiply. I have 12 times 15 plus X equals 20 times 15. I need to distribute my 12. So 12 times 15. It's going to be 180 plus 12x equals 15 times 20, which equals 300. Let's subtract 180. We're going to get 12x equals 120. Divide by 12, and we get x equals 10. That x again represents CE. So that means that CE is equal to 10. Okay, so number 25. Again, we're dealing with ratios here. So if we look at A, it's saying that the ratio DF over something is equal to the same as CE over AC. What goes with AC on the other side? BD. So in this blank here, we would say this is BD. Those go together. Now let's look at B. For B, they're saying AE, so the whole thing is on top over AC equals something over BD. Well, what am I missing? The whole thing over here. So that would be BF. We're just setting up proportions on that one. That's it. Okay, 26. Now we're dealing with mid-segments. So it says that AB and CB are mid-segments of triangle XYZ. Find each measure. A asks us to find the measure of angle BCZ. So that would be that angle right there. BCZ. Well, I'm only given one other angle, that 42. How is that 42 and the angle I want related? They're alternate interior angles. And what do we know about alternate interior angles? They're congruent. So that means the angle I want is 42 degrees. Next, they ask about BC. Well, BC is this mid-segment right here. It's a mid-segment. How do I go from the side that's parallel to it to the mid-segment? Gotta divide by 2. So 70.2 divided by 2 is 35.1. That's it. That's all BC is. BC is 35.1. Now they ask about XC. So down below, XC. XC is half of the side that's parallel to our mid-segment. That means it has to be the same as our mid-segment. That's going to be 32.4, just like CZ has to be 32.4. So XC is 32.4, which makes XZ the whole thing over here. So 32.4 plus 32.4. It's going to be 8, put your decimal, 64.8. Now I went through that kind of quick. If you need to go back and rewatch it, well, go back. No one's stopping you. Go back and rewatch it. That way you can make sure you know how to do that. Okay, so for number 27, we're going to use the mid-segments to find the value of x. So use the mid-segments to find the value of x. Now, just like we saw on 26, remember the mid segment is half of the side it's parallel to. Or you could say 2 times the mid segment is equal to the side it's parallel to. However you want to say it. So for A, 3x plus 6, and then you got the 2x. Well, to get x, I'm going to have to multiply this 2x times 2 because it is our mid-segment. So 2 times 2x equals 3x plus 6. 2 times 2 is 4. So I'm going to have 4x equals 3x plus 6. Subtract the 3x, and we get x equals 6. And since that's what they ask us to find, that's our answer. X equals 6. Now for B, I have this 2x plus 4 out here, but to set it equal, I need to multiply the 12 times 2. That's going to get me what this is really equal to. So 2x minus 4 equals 12 times 2. 12 times 2 is 24. So I have 2x minus 4 equals 24. I add my 4. I'm going to get 2x equals 28. Divide by 2 on both sides, I get x equals 14. So there's my x. X is 14. Okay, so that's 27. Now we have 28. So they want us to write the angles in order from smallest to largest. So here we're dealing with angles. Now remember, the smallest angle is across from the smallest side. So here's my smallest side. If I go across from it, I'll land at F. That means F is my smallest angle. So angle F comes first. Then I need to look for the next smallest side. So it looks like that 7.1 is our next smallest. So then I go across from it and land at angle H. That means angle H comes next. And then that means our third angle is the only one that's left. It's angle G. And then we could do the reverse of that. If we wanted to list the sides from shortest to longest, well, you find your smallest angle, and then across from it is your shortest side. 43 is my smallest. I go across from that and I land at BC. So that's going to be my smallest side, BC. Then I look for the next one. So the next one's 46. I need to look across from it. And I land on C8. So CA is the next one, which means the last one would be AB. That's the last one available. So there's our 3 sides from shortest to longest. Number 30, we're doing the same thing, but now we need to draw our own picture. So triangle RST. RST. Now it says R is my shortest, then S, then T. So let's look across from R, because that would give me my shortest side. So that means that ST is my shortest side, which throws out F, it throws out G. So then my middle angle is S. I go across from S. That'll be RT is my middle side. H is good. J gets thrown out. So then, yes, my third side would be RS, which leaves me with H as my answer. Okay, for 31, we have to say whether a triangle can have sides with the given lengths. Well, let's see. So remember, we have to find the two smallest, add them together, and then together they have to be greater than our largest side. So we're going to need to add 3 plus 7. That's going to equal 10. How is 10 equal to 10? Or how is 10? It's equal to 10, our biggest side. This is not good. We don't want equal. So this would be a no. Next one. 11 plus 14. That gives us 25, which is greater than 20. That's a good thing. So this one can be a triangle. Then the next one. 6 plus 8 is 14. How does 14 compare to 16? It's less than. That's bad. So this one cannot be a triangle. Okay, 32, we have to compare some sides here, or some angles. So first they want us to compare angle T with angle C. So let's look across from those angles. Which one is bigger, 6.6 or 6? 6.6 is bigger. So that means the measure of angle T is greater than the measure of angle C. Okay. Then they want me to compare ST and KL. I need to look across from those at the angles given. Which angle is bigger, 75 degrees or 44? 75 is bigger. So that means that KL is greater than ST. Okay, so for 33, we have to do the cross product or the butterfly method. or cross multiplying, whatever you call it. That's what we've got to do. So we need to do A times 16, which we can just say is 16A. It's going to be equal to 8 times 10. 8 times 10. So that's 16A equals 80. Divide by 16, and we end up with A equals 5. Okay, letter B. We have to do 9 times 2. 9 times 2 equals B times 3, which we'll say is just 3B. So 18 equals 3B. Divide by 3. And we'll end up with essentially B equals 6. And then we got C. So 5 times 6 equals 3 times X. 5 times 6 is 30. Divide both sides by 3, and we get X equals 10. Okay, 34. The ratio of side lengths of a quadrilateral is 3 to 4 to 5 to 6, and the perimeter is 216 centimeters. What's the length of the shortest side? Well, let's first figure out what our constant is that we're multiplying by each time. So we'll say 3x plus 4x plus 5x plus 6x equals 216. If I combine all my x's together, I'll get 18x. 18x equals 216. Divide by 18, and we get x equals 12. Now, like I said in class, let's find all of them and then see what the question asks. So we can do 3 times 12, which gets us 36. 4 times 12 is 48. 5 times 12 is 60. 6 times 12 is 72. Now, the question says, what's the shortest side? Well, that's going to be our 36. So we'll say 36 centimeters. That's our shortest side. Okay, 35. The ratio of the angle measures in a triangle is 3 to 12, 3 to 10 to 12. What's the measure of each angle? So I'm going to kind of break this up right here so I have room to work. Let's say 3x plus 10x plus 12x. We're dealing with angles in a triangle, so this would be 180. 1025. So I'm going to get 25x equals 180. Divide by 25. And we get x equals like 7.2. Now they asked me to find each angle. So I do have to plug in for each and every one. 3 times 7.2 is 21.6. 10 times 7.2, that's 72. And then 12 times 7.2, it's going to be 86.4. So our three angles are going to be 21.6 degrees, 72 degrees, and then 86.4 degrees. Okay, last one. M.C. Escher's lithograph drawing hands is 28.5 centimeters wide and 34 centimeters long. Nathan has a poster hanging in his room. The poster is 85 centimeters long. The poster is similar to the lithograph. How wide is it? Well, let's see. Let's do the original equal to the poster. And let's do width over length. So for the original, we're going to have 28.5 over 34. It's going to equal, let's see, the poster gives us 85 centimeters long. So x over 85. So now we've got to cross multiply. 28.5 times 85 equals 34x. 28.5 times 85 is 22.5 equals 34x. Divide by 34. And we get 71.25 equals x. The x is how wide it is. So our poster is 71.25 centimeters wide. Okay, that's it for the review. Hopefully that's really starting to sink in because tomorrow's the test. So make sure you know it. If you don't, come ask me questions in the morning. So anyways, there's a review. Good luck on the test.